else basically from the standards we are considering 33% of our daily requirement in OST. We are going to store that water in OST, the remaining 67% in UGT. Get it? But for practical cases, it won't be possible. So that based on the consideration, or else based on the requirement, we might be storing like 15% or else 20% in OST, remaining 80% will be in UGT. Then after we have discussed, there should be a pump, isn't it? And for pump also there is a pump sizing calculation from the plumbing design engineer side, and he need to suggest what will be the capacity of the pump, considering two things. One is it should not reduce in the sense the pump capacity should not reduce, or else it should not increase. Both causes some problem. Yesterday we have discussed that also. See, then after sizing the pump, then what he has to do in the sense, from OST only we need to start our supply pipes, isn't it? Supply pipes in the sense, we know this building is of G+10. In the sense, for all the 10 floors, there should be a proper supply from OST. And one more thing, because here there might be an issue when they are installing the supply pipes, because the pressure in the 10th floor and pressure in the second floor, or pressure in the ground floor will be too different, isn't it? Pressure will be different, water pressure will be different. So in order to compensate for this, what they'll do, sometimes they'll be using the pressure reducing valve wherever required, or else sometimes if they need to increase the pressure, they will be using some pneumatic system, or else some actuators they will be using here. Getting it? So this is what we have discussed in the previous session. Now supply, I told you, okay, supply in the sense, different types of supply pipe sizes will be there. For that, the plumbing design engineer, what they will do, they'll be handling it with a software, and which is named as the pipe sizer software. Even they have a separate software in order to calculate the pipe sizes for different supply pipes. And one more, see, even if a plumbing design engineer, he need to suggest, even see, we might have noticed in the washrooms that ablution tap, that pipe size will be different. Then our regular tap will be there, that pipe size will be different. Then for our water heater, pipe size will be different, material also will be different. We might have noticed this. See, these are all things he need to suggest to the client based on his consideration and calculation, and also based on the plumbing standards, which are all IPC, UPC, and NPC. So IPC, UPC, NPC, and NPC. Please, one more thing in the sense, see, okay, supply, a plumbing design engineer, he is going to deal like this. Then what about the drainage? Drainage, it might be a complicated thing in plumbing, isn't it? Because there should not be any fault, or else there should not be an error, there should not be any installation error. Because once the drainage has been installed, in the sense everybody in that building, they will be using that regularly. Then if there is a maintenance, or else if there is a fault, if there is an error, then what happens? So it is very difficult to fix that issue. That's the reason always the drainage should be in proper, and the regular system which we are using in drainage will be like this. Schematically, I'll just represent here. You can understand that. One thing, imagine this is one drain pipe, and we have one more drain pipe here. Then we have one more drain pipe here, will be here. See, in most of the buildings also, outside of the building, we can see this sometimes, drain pipes, because they will be providing the drain pipes sometimes on the walls, outside of the walls. Most of the times what they will do, in order to cover all this drainage system, so they will be using the routing through our ceiling gap, isn't it? In the sense that we are going to discuss later, ceiling gap, false ceiling gap, true ceiling, what is that? Those things we will discuss. But even though, I'll give you some information, like, see, for most of the buildings nowadays, there will be a false ceiling. In the sense, there will be a gypsum ceiling, isn't it? We might have seen this. So within that gypsum ceiling gap, in the sense from gypsum ceiling to true ceiling, there will be a ceiling gap, isn't it? So within that ceiling gap, nowadays in most of the buildings, the engineers, they are trying to hide the things like our HVAC system, in the sense duct related to HVAC system, then cables, conduits, or else any connections related to electrical, they are going to hide inside that. Then plumbing, supply, and drainage pipes, they are going to hide inside that. Then after, our firefighting systems, firefighting pipes also will be separate. So in order to have the routing, they will be hiding, or else they will be taking the routing within that fall ceiling gap. And see here, I'll mention here it is. So this one is our soil pipes. See, basically we have three main drainage pipes. One is your soil pipe, another one is our waste pipe, then the highest one is our vent pipe. There will be majorly in each and every building there will be one soil pipe, one waste pipe, and one vent pipe. Here, so for example, let me. For example, if this is your 10th floor and this is your 9th floor, imagine this is your front view. Getting front view from outside of the building. Getting. Then this is your 10th floor and this is your 9th floor. Or else consider this is your 10th floor, this is your 9th floor. This floor is 10th floor and this one is your 9th floor. From our related to our project, I am telling. Getting. Then if you have a water closet, 1, 2, or 3, whatever the number of water closets available, sorry, not here, whatever the number of water closets available in this particular 10th floor, see here we are going to connect that water closet to this soil pipe. Getting? So to the soil pipe, we will be connecting all the water closets along the water closets. We are going to connect to the soil pipe. See, soil pipe in the sense, the name is soil pipe. Don't think that is the material is soil. Getting? Always it will be PVC or UPVC only, drainage pipe, because almost all the drain pipes will be of PVC or UPVC. So water closets we will be connecting in this manner in 10th floor, then 9th floor, then 8th floor, like this we will be connecting, so that there will be a proper flow through this soil pipe. Same way, see, soil pipe, I told you, again I am repeating it, soil pipe in the sense the material is not made up of soil. Getting? It will be PVC or UPVC. But for understanding, see, they have given this name soil pipe. Soil pipe in the sense the soil type of drain pipe, in the sense always only water closets we are going to connect with this drain pipe. Now we have our waste pipe. See, apart from our water closets, we'll be having the kitchen sink, wash basin, isn't it? Kitchen sink we will be having. Same way, wash basins we will be having. Then floor trap we will be having. So we'll be having some other sanitaries, isn't it, related to plumbing. So this one, what they will do, they are going to connect to the waste pipe. See, there is a motive behind this. I'll explain you. See, apart from our water closets, our kitchen sink, wash basin, or floor trap, whatever it is, they are going to connect it with the waste pipe in all the floors. So in all the floors, the connection will be like this. What exactly? Water closet. Water closet in the sense our normal closets, washroom closets will be there now. That is what the water closet. Getting? Either it might be European type of water closets, or else it will be Indian type of water closets, isn't it? That is part of our daily life, isn't it? Now, So alone water closets we are going to connect to the soil pipe. Then apart from water closets like kitchen sink, wash basin and floor trap, whatever it is, we are going to connect that with waste pipe in this manner. The reason in all the floors the connections will be like this. Then there is a reason why we are not connecting the water closet to this particular waste pipe. That is nothing but see the end of the water pipe or else end of this drain pipe, we are going to connect it with an SWT. We are going to connect it with an SWT. SWT in the sense we can make a note of that. See, it is known, isn't it? Sewage water treatment plant. That is what SWT. Sewage water treatment plant. So once if the water is recycled, see water from our waste pipe, it can be recycled. See, these are all technical details related to the drain pipes. See, water from the water closets, it might be, it can be recycled. Getting? Now, after recycling, the water is known as, you can make a note of that also might be an interview question. Recycled water is known as grey water. And don't think that will be in gray color. See, the name given for that recycled water is gray water. In the industry, in MEP industry, most of the in plumbing industry, so they will be using rather than recycled water, they will be using this name gray water, and the color will be almost like our normal water only. And the recycled water will be pumping, or else there will be some other arrangement to get that water to our water closets or else our flush tanks, so that we are not going to touch the water. In some of the buildings, if water is not available or water resources are not proper, then what they will do for some other gardening purpose also, they will use this recycled water. Getting? So water from our waste pipe, it can be recycled. The recycled water is named as grey water. Hope everybody understood this. Now we left with one more, vent pipe. See, vent pipe, intention of providing this vent pipe, that is to expel out, the foul smell or else odors. Getting? And also to regulate the proper flow of these two pipes. And here the connection will be like this. See, from vent pipe to soil pipe, the connection will be like this. So there won't be any backflow. Only that air will be flowing, and top of the vent pipe will be an open. There will be some grooves or there will be some openings. There will be an end cap, but in that end cap itself, there will be some openings. See, we people might have noticed it already, isn't it? And to waste pipe also, we are going to connect it like this. So there won't be any backflow. Getting? Hope everybody understood this. And the height of the vent pipe always it will be more than that, more than the height of our building itself, because in order to, so kitchen sink, wash basin, floor, something else. What? Can you please explain again? See, FT in the sense, it is nothing. Somebody is asking there. It's FT in the sense that is floor trap. Because when we are cleaning our floor, see, there will be a trap, isn't it? In order to flow that water, in order to flow that used water, or else that clean the water properly into our drain pipe, there will be a trap. There will be an opening within the floor itself. That is what floor trap. Getting? See, some technical things are there related to this. Even for kitchen sinks also. See, underneath of our kitchen sink, there will be a proper arrangement. Like you can say that fitting is named as bottle trap. That fitting. So it will be like this. I don't know how can I annotate that. Trap will be like this. Will be like this. Because all the waste from our kitchen sink or wash basin, it will sediment here. Whenever we are using this kitchen sink or wash basin, then it will overflow. So if there is a blockage, there is a block for this wash basin, then what happens? Immediately we can open this portion. So this portion is named as a bottle trap. Getting? See, bend pipe in the sense I told you, always it will be in a height which is more than the height of our building, because the false smell or else orders, it has to go to the atmosphere. There should not be any contamination which nearby to our last floor. So in this particular project, it is G plus 10. So in 10th floor, there won't be any disturbance or else there won't be any false smell through the vent pipe. So that's the reason more than our building, they will be extending this vent pipe height. Getting? So generally, once again, water closets we will be connecting to the soil pipes, and apart from water closets, we will be connecting all the sanitaries like kitchen sink, wash basin, floor trap to the waste pipe, because we can recycle the water from our waste pipe. Getting? Like we will be having an SWT plan. A plumbing design engineer, he will be suggesting the size of this SWT plant also. The tank also, in order to collect the waste water from this waste pipe, see that tank sizing also he need to suggest. Even rainwater harvesting also he need to suggest related to building. Then one more, even septic tank sizing also a plumbing design engineer he need to suggest. Getting? Now, function of NPI is to expel orders. Nothing, that is to expel orders or foul smell, and also to regulate the flow. See the bend pipe, I told you it is going to connect in this manner. So always we will be having an end cap, and in the end cap itself there will be some opening. So there will be a proper airflow, in the sense which is going to help the waste particle or sediments within the soil pipe or waste pipe to properly flow. Getting? I have a simple question that I wanted to ask you. See, in almost all the water closets, even it is Indian style or European type, then there an amount of water will be available inside the water closets always, isn't it? So why we have to maintain that water closet? Sorry, why we have to maintain that small amount of water inside the water closet? General suggestions I need, or else you can think technically also. Why we have to maintain a small amount of water inside our water closets, whatever it is, either it is Indian style or European style. Always we know that is it. Proper flow of wastage to maintain pressure in case there is no water remaining in pump. Now then reduce friction to avoid bad odor, avoid airflow. Fine. Thank you. Let me explain. See, we can say to flush properly or else to avoid orders, that is one thing, and avoid air block or else reduce friction, whatever it is, those things are general. But two major reasons are there. One is, imagine this is a water closet, and we'll be underneath of your water closets, we'll be having a U-trap like this, isn't it? There will be a U-trap. Because we have noticed that, isn't it? So here there will be some water. Always there will be some water in the U-trap. So if our water closets we have connected with this pipe, then what happens? If somebody is using this water, so this water will be resembling here, isn't it? Here itself our water closet is going to connect with this pipe. Then within the U-trap always there will be water because of this arrangement. So whenever we will flushing the water along with the sedimented material or as a waste material, it will overflow like this. Again, the water will remain here, isn't it? The reason at the end of this, see the end of the soil pipe, we are going to connect our soil pipe either to our septic tank or else to our corporation manhole, isn't it? Directly in most of the metro cities, always the end of the soil pipe will be connected to the corporation manhole only, because there won't be proper space in the ground in order to provide an UGT OST for our supply or for our normal water purpose, and nearby to that we can't able to provide any septic tank. That's the reason always what they will do for easiness also, directly they will connect this with the corporation manhole, which whatever it is, either they are connecting it with the corporation manhole, or else if they are maintaining a separate septic tank, then what happens? There are two reasons I told you. One is, if you are not maintaining the water here, so that it will be an open space, isn't it? Then what happens? So entire foul smell from our septic tank or else the corporation manhole, it can reach to our space, isn't it? It can reach to our washroom space, so we cannot able to stay inside. That is one thing. Then second thing, the bees or flies, whichever it is, so bees or flies, always it will be available in the waste, isn't it? Inside the drain pipes, inside the septic tank, nearby the septic tank. So it should not come inside our space. So these are the two technical reasons related to water closets. Hope everybody understood this. So in plumbing, we have started with the G+10 building. We have calculated the water requirement. Now, so once again, let me revise the things. So in plumbing, what we have done, we have considered a G+10 building. For that, we have become a plumbing design engineer. We have calculated the water requirement. Then number of people, based on that OST, UGT constructions, how they will, how a plumbing design engineer, he will suggest his client the size of the UGT, size of the OST, then how will be the supply, then how will be the drainage, how will be the connection in the drainage, then how we are going to recycle the water. So which are all the major general terms related to drainage pipes. Then some of the information related to water closets, then recycled water name, isn't it? These are all the things we have discussed till now. Hope everybody understood this. Getting now. Okay. So under MEP, we have discussed about HVAC. Initially, what is heating, what is plumbing, sorry, what is heating, what is ventilation, what is air conditioning. That thing we have discussed. And codes and standards we are using for HVAC, that we have discussed. Then electrical, how an electrical engineer he is designing a system based on what are all the consideration, what are all the things he need to calculate. Those things we have discussed. Then after we have discussed about plumbing, isn't it? Now we have one more major topic, which is nothing but firefighting. See, firefighting, this is also a platform in the MEP industry. Getting apart from our HVAC, electrical and plumbing, so this is also a major part of our MEP industry. For example, see, whatever the system, HVAC system or electrical system or plumbing system has been provided for a particular building, then even though for safety measures, or else in order to provide the safety measures to a building, always there should be a proper firefighting system. See, firefighting system in this sense, see, we have seen some of the things related to firefighting, isn't it? Let me share. Let me share my screen to you. See, when we are visiting a mall or a hospital, in the parking basement, we might have seen these type of pipes, isn't it? Isn't it? Red color pipes will be there in the parking basement, especially. And we might have seen, see these type of arrangement also, isn't it? Fine. See, these are all, and one more general thing, fire extinguishers. Always it will be there in our college, isn't it? Fire extinguishers will be there. Then fire exit will be there separate, isn't it? Then hose reel will be there. If your college building is of an infrastructure building, then all these things will be there. Fire exit, hose rack, separate red color cabinet will be there. That is hose reel. Inside that hose reel will be there. That separate cabinet itself is known as hose rack. Getting? So many things we have seen in our daily life, but even though we don't know either it is related to our engineering or else our core engineering or not. See, this is also exactly related to our engineering in MEP industry. Getting in MEP industry, this is an important platform. Getting? See, majorly there are in order to provide the safety for a building, in the sense safety for a building from fire. Always there should be some system. If there is a fire inside a building, in order to control that fire, always there should be a system. Because see, for example, see, in plumbing we have been using NBC, isn't it? National Building Codes, isn't it? Based on that national, see, same NBC, even civil people also they are going to use NBC standard, National Building Codes. So in that clearly it is mentioning always, see, these four systems should be properly provided for a building. Four system in the sense HVAC, electrical, plumbing, and firefighting, because they need to get the final approval also. Getting? So this is what the modern industry is. We can say it is updated one. So each and everything should be properly provided for each and every building. Then only we will be getting the approval from the regulating authorities. Getting? Or else from our clients. See, here in the firefighting system, we have codes and standards. I'll explain you that later. But before that, majorly we have three types of firefighting systems. You can make a note of that. Majorly we have three types of firefighting systems in our industry. One is your sprinkler system. Second one is our gas suppression system. Gas suppression system, and third one is a foam system. You can make a note of this. I'll give you some general details about this. That's all. That is what we need, because in order to understand what is that. See, generally there are three types of systems in firefighting. One is our sprinkler system. Second one is our gas suppression system, and third one is our foam system. Correct. See, sprinkler system in the sense, always we have seen that in most of the commercial type of buildings, or whatever industrial type of buildings also in India, then generally we have seen this sprinkler system. That's the reason. So I showed you the sprinkler. So this is what we were discussing, isn't it? See, this is a single sprinkler, and in all the firefighting system, if it is, or else if we are using a sprinkler type of firefighting system, then always for a building there will be separate tank, or else there will be a separate water tank for firefighting purpose for each and every building. Getting? Only sometimes only we will be using the part of water which we will use for our normal purpose in a building. But always, and it has been an information from the regulating authorities related to firefighting. Always we have to use a separate storage tank for this firefighting system if we are using a sprinkler type of firefighting system for a building. See, let's see how a sprinkler goes. See, imagine this sprinkler is connected with the pipeline also, that supply pipeline also, that will be pressurized pipelines. In the sense, see, if the sprinkler is being connected with the pipeline, then you can say it has been connected with the pressurized pipeline or firefighting, isn't it? Pressurized firefighting pipeline, it is being connected. Now, see, here we have one special arrangement in the sprinkler. See, here we have a glass bulb. So this is a glass bulb. Inside this glass bulb, there is a liquid, and in the industry it is named as red alcohol. So based on the nature of the fire, or else based on the nature of the building, so this color might be changing, and even the content, or else the chemical, or else the substance itself will be changing. So here they see, here in this particular image it is red alcohol. Fine. Inside this glass bulb we are having a red alcohol. Then tip of this, see, always inside a sprinkler, inside the glass bulb, on the tip of the glass bulb, see, there will be an air bubble. So if there is a fire inside this space, then immediately this red alcohol will sense that temperature. If it is more than 50 degree or 60 degrees Celsius, then immediately it will sense, and try to expand. The arrangement itself is like bulb is going to explode. As a result of that, see, this red alcohol will come out, and this will be an opening. Hope my voice is clear to you. So when the glass bulb is exploding, then it will be an opening. The pressurized water inside the pipeline will flow over this. It will spread everywhere within that region. Within that region, in the sense, don't think that only one sprinkler we are going to provide for a single space, isn't it? One sprinkler, in the sense, it is going to control the fire within the range of 5 to 10 square feet. That's all. So based on that also, a firefighting design engineer, he need to suggest to the client. When is amazing to used for fire detection? Could you explain again? You was kind of for a while. See, I told you different types of, or else different types of substances, or else different types of liquids we'll be using here. That is based on the nature of the building. See, nature of the building, in the sense, for example, the fire from a normal residential type of building will be different. Fire from a commercial office space will be different. The fire from an oil and gas sector will be different, especially in the rig. If there is a fire, then it will be a huge fire, isn't it? So based on this, they will be using, based on this, those information we will be getting from the standard. That's the reason I told you, see, even we need to consider some of the standards related to this, as we have ASHRAE and ISHRAE for HVAC, and NEC IS for electrical, and IPC, UPC, and NPC, NBC for plumbing. Here also we have some regulating authorities. See, that regulating authorities is named as NFPA, National Fire Protecting Authority. So here in India, we will be making use of this NFPA 13. So it's, sorry, 13 is a chapter. Most generally, we will be using the NFPA. NFPA, in the sense, you can make a note of that. That is National Fire Protection Authority. Totally, see, somebody in the firefighting system, we will be having 3 different categories. One is sprinkler system, second one is gas suppression system, then third one is a foam system. Now, see, I have seen a major drawback when we are using this sprinkler system. For example, if we are providing, always if you are providing the sprinkler system for each and every type of building, then there are some drawbacks also. Major thing is nothing but, see, sprinkler system we can provide for our normal residential type of building, isn't it? For some of the commercial type of buildings also we can provide the sprinkler. See, when we are providing this sprinkler system, especially for a commercial office building or else an IT industry, then what happens? See, if there is a fire within the system, or else especially for server rooms, if there is a fire within the building, then see, this sprinkler system is going to control the fire within sometimes, or else within the designed span of time, it is going to control the fire. But the major issue is that same time, because water will spread everywhere, isn't it? Within the space itself. So sometimes we are going to we may going to lose our assets also, or else there will be a huge loss for the building. Like, if you are losing our assets like our computers or also valuable documents, then what happens? See, then it is a major drawback from a sprinkler system. So it depends on the building requirement. Even in a sprinkler also, as somebody have asked, in a sprinkler also, the substance itself will be different based on the nature of the fire. Even for our fire extinguishers also, you might have seen that clearly it will be written as A plus B, B plus C, C plus D. See, that is also based on the nature of the fire from the building. Getting the fire from the wood it will be different, fire from the oil it will be different. So based on the purpose of that building, or based on the nature of the building, a firefighting engineer, he is going to suggest, okay, this will be the system, and in what distance we have to see, if you are considering a sprinkler system, in what distance we have to fix two sprinklers, or what should be the maximum distance we can maintain in between two sprinklers. Then what type of supports we have to provide for the pipes, and what type of supports we have to provide for the sprinklers. Those things also we need to discuss. Sorry, those things also he'll be suggesting, as a firefighting engineer will be suggesting to the client. See, I was explaining, the major drawback of sprinkler system when we are using the same system for a commercial office building or else an IT industry, then there will be a huge loss, isn't it? At least there we are going to, or else the system is going to damage some of the assets. So in this reason, in some of the spaces, or else in more throughout the building itself, they will be choosing this gas suppression system. Getting. So by making use of the inert gases, gas suppression system, how it works in the sense, imagine we have, for example, we have a server room. Getting. So in that server room, we will be having a server, or else if it is a work area, then we will be having the systems and some other assets too, isn't it? So there everything will be properly installed, and after, if there is a fire, then immediately the fire alarm which is available, or else which is connected with that space, that is going to trigger. The fire alarm will start and it will last for 30 seconds or else 1 minute. That depends on the design. So within that 1 minute, the occupants inside the space, occupants inside that closed space, they have to evacuate themselves. Through they can make use of the fire exit, and there will be a separate safe assembly point, so that what they can do, they can assemble in that safe assembly point. Within that 1 minute or else 2 minutes, whatever has designed by a firefighting engineer, within that, after 2 minutes or 1 minute, then what happens? That system will work and it will control the fire. It will be a closed system. It will be a closed space. All the doors and windows will shut down automatically. Then the system will work so that it can control the fire. That is what related to gas suppression system. Same way, foam system. Foam system majorly, this foam system will be using in industries, or else especially in oil and gas sector, or else in industries wherever the heat generation is more, or else natural fire, or else the more chances of a fire. See, somebody is suggesting in that case, we can use sensors in IT company. Sensors in the sense, I don't understand what type of sensors we are going to use in the IT company. See, those also. So in order to sense the temperature, there will be some arrangements in the system itself, firefighting system itself. See, that is the reason. That is the reason. Whenever there is a fire, the system will work, isn't it? So I have given some details about the firefighting system, like what are all the general types of systems we are using in firefighting, like sprinkler system, gas suppression system, foam system, whatever it is. Then the design will be based on NFPA, and you can make a note of this. NFPA in the sense that is National Fire Protection Authority. NFPA in the sense that is National Fire Protection Authority. This might be an interview question. Hope everybody understood this. Now we need to undergo few more basics, like what are the profiles in HVAC we have. In the sense, what are all the job designations we have in related to HVAC. Then, so today we have discussed some other information related to plumbing apart from the last session. Then we have discussed about the firefighting systems. Then here we have one more topic, that is nothing but profiles in HVAC or else HVAC. See, the different profiles in HVAC we can consider. One is our sales profile, then second one is our design profile, then third one is our execution, or else you can say that is project management. Execution, or else you can say that is execution or else project management. Then fourth one, we can say it is maintenance. So these are the major four profiles which we have in HVAC. First thing is sales, second thing is design, and third one is execution, fourth one is maintenance. Let me explain one by one. See, before that, consider, see, these four different departments are available in an MEP company, and that company is into some of the MEP parts production also. So, so some of the MEP parts production also, that also they have. So that throughout the area in MEP, they will be familiar in the industry, or they will be familiar in the region. So what happens? How we are here? How an MEP company they are getting a project in the sense. See, in order to do some sales within the company itself, or else in order to get some project. So in that region, see this sales people, they will be continuously they will be approaching one or two categories here. So that is nothing but they will be approaching our architects or else our MEP contractors, or else you can say our civil design engineers. You can say our civil engineers continuously, or else in between this there are one or two more categories are there. I'll explain you that later. Let me come to the point now. So within the company, in order to do some sales, or else in order to get a project related to MEP or HVAC, for example HVAC, then see this sales team always they have to be in the market and they'll be searching for the projects. See, they'll be searching for the project in the sense how, if there is any construction related to any of the building, or else in the future, or else in the next two years, or else in the next 3 years, if there is any expansion work, then they should analyze that. They have to understand, they have to get the information so early from this architects or else MEP contractors, civil engineers, authorized architects or MEP contractors, civil engineer. They will be available in all the regions, isn't it? So they will be holding a project in the first phase. See, because first thing is starting from architects or civil engineers, isn't it? I think because first thing they need to execute the civil structure, then only we can provide the services, MEP services. So when they are repeatedly contacting this architects, MEP contractors or civil engineers, if these people is holding a new project and that project they are going to execute in the next year, then what they'll do, they'll be having that plans, isn't it? Architects or civil plans they'll be having, isn't it? AutoCAD plans they'll be having. So those plans, or else if there is an actual requirement to for an HVAC system, then they'll be conveying or they'll be passing the message to the sales team. Okay, we are in requirement for a team of HVAC design engineers because we have some expansion work or else we have some new projects. In order to design the HVAC system, we need a number of people or else we need a number of engineers, and they'll be conveying the message to sales, and they'll be inquiring, do they have a separate design department in their company itself? Then they'll agree that, they'll say yes. Then as a result of this, they'll go through the project. Will it be a profitable one, or else they have to face any kind of risk? Those things they'll analyze the project, and if everything is good, they'll try to get that, or they'll do in the tendering stage. They'll submit their quotations related to that. What will be the charges? What are all the expenses? And laborers, details, everything they'll be submitting through their in the tendering phase itself. Get it? Then, if everything is okay, then if these people, if the client side, if they are ready to give the project to them, then there will be an official document for awarding the project, so that they will receive that, and based on the terms and condition, both they will be having separate contract. There will be some contractual terms also. Then after signing, both the people, see, based on some of the bank securities also, see, there are some conditions or else there are some regular procedures. So by following all these procedures, the sales people, they'll be getting that project. Getting. Now what they will do, they'll reward that project to the design team within their company itself. So the design team will analyze the project, how they can design a cost-effective HVAC system. They'll analyze and they'll inquire where they are going to execute this particular project, and then based on that region climatic condition, then heat generation in each and every space, then based on the type of building they'll be designing, or they'll be calculating all the required things by making use of the standard, and then after they'll be designing a cost effective system for this particular building which they have got from their architects or clients or whoever it is, MEP contractor or civil engineer. Then after designing, they'll submit the same HVAC design project to the architects, because these architects or MEP contractors always they'll be having very good knowledge in that. So they'll analyze, and if everything is good, and what they will do, they will give the approval to do the execution. Then the same project will be handed over to execution team or else project management team. So these people, they will visit the site and they'll arrange the laborers. They'll attend some of the safety induction classes before commencing the execution. See, some of the safety induction classes also will be there in the site, and they have to apply for that. You see, if our project is happening in the ministries, or if our project is happening in the port related projects, or also airport expansion, then always, in order to enter into the site, each and everybody should have a gate pass. So 1 month prior to the execution work, or else at least 15 days prior to the execution work, they have to apply for the gate pass, and even for their vehicle or company vehicle also, they need to apply for the passes. Then only they can access the site. Hence, there are so many things related to execution also, and then they need to submit the method of work. Method of work in the sense how they are going to execute these things, what are all the tools they are going to use inside. So those information also they have to provide to the client, and if the client said if they are approving, then only we can carry all these tools to the site. Not like Indian condition, because in Indian condition we can do whatever we want, but in most of the Middle East region, these processes will be complicated one, because in some of the ministry projects, whenever whenever we are working in some of the ministries project, then getting the gate pass itself is a huge task. So those things will be handling by the execution team, getting, and after everything is fine, then they'll purchase everything based on the requirement, based on the design. They'll execute a cost-effective system. Now, then after, they'll give that to maintenance team, or else they'll reward the project to the maintenance team. Once the execution is over, there is a process which is named as key handover. So they'll do that with the architects through the sales team, because always the sales team will be familiar with the architects. So if they want any information, they'll be asking here, or else directly they can ask here. All the things will be recorded, all the conversation will be through email, so that everything will be recorded. Then maintenance team, they will be documenting all the things related to the indoor, outdoor, whatever the equipments are there, they'll document it, and they'll be starting their maintenance. So once in a while, or else once in 3 months, once in 6 months, depends on the requirement, they'll be doing the maintenance. Getting. Hope everybody understood the session and enjoy the session. See, some